Okay, we continue with the normal distribution. Okay. Now we will learn how to transform any normal variable x to the normal random variable z. Let's say you have x normally distribute with mu and sigma square. So it is actually, we can convert into z-score with the formula of x minus mu divided by sigma. It can be shown that the mean and variance of the normal variable z are 0 and 1 respectively as below. Okay, let's say you have here the mean or the expectation of z is actually x minus mu divided by sigma. So by factorize 1 over sigma, you will have the expectation of x minus mu. So mean minus mean. So mean minus mean is 0. Multiply with 1 over sigma, then you will get the mean is 0. Now let's we prove the variance is equal to 1. So the variance, we have the variance of z is x minus mu over sigma. Since this is the variance, factorize of sigma 1 over sigma square, then the variance of x is sigma square. So sigma square multiply 1 over sigma square is equal to 1. So this is proof. Therefore, when x is normally distributed with mu and sigma square is actually approximate to the z normally distribute with the mean 0 and the variance 1. And we can write as the function of z is 1 over square root 2 pi e power of negative z square over z from negative infinity to infinity. And then with the mean value of 0 and the variance is 1, the shape of the normal curve is narrower and sharper and centered at 0 on the horizontal axis. So here is the curve of the standard normal distribution where the mean is 0. Let's we look into the example how you want to find the value of C when you are given the probability of the C. Okay, so let's say here you have the X is normally distributed with 2, 4, mean 2 and the variance is 4. You need to find what is the value of C if the probability of the C are given, right? So we know that to approximate from normal distribute to standard normal distribute is x minus mu over sigma. So here, if probability of x greater than c, therefore it is equal to probability of z greater than c minus mu over sigma. Okay, the first one, probability of x greater than c is 0.35. So you need to find the value in the Z table or standard normal distribute table. All right, 0.35. So you can find here is convert to Z score first. Then you have here probability of Z greater than C minus 2 over 2 because the mean or mu is 2 and the sigma is 2 because square root of 4. All right, is equal to 0.35. Then from the table, 0.35 is here. So first you look into the value of Z. All right, the value of Z is 0.3. Now, you will refer to the row. The first row is 0.08. So 0.3 plus 0.08 is actually equal to 0.38. So the value of C based on the table with the given probability 0.35 is 0.38. Then C minus 2 over 2 is equal to 0.38. Then you can find the value of C is 2.76. Next is the probability of X less than C is 0.75. Find the value of C. First is you need to approximate from the normal distribution to the standard normal distribution. All right. C minus 2 over 2. So P P Z less than C minus 2 over 2 equal to 0.75. We know that the value in the statistical table here is always greater than the value. Alright, so Z greater than C minus 2 over 2 is actually 0.25. Alright, so because 1 minus 0.75 is equal to 0.25. So probability of Z greater than C minus 2 over 2 equal to 0.25. Find the value of 0.25 in the statistical table here. You have the closest value is 0.2514. So the first column is 0.6 and the first row is 0.07. Therefore, from the normal table, we get the value of probability of Z greater than 0.67 is equal to 0.25. So now equating the value C minus 2 over 2 equal to 0.67. Therefore, the value of C is 3.34. Next is, given that the probability P X greater than C is 0.83. So the same method, since this is greater, C minus 2 over 2 is equal to 0.83. However, based on your statistical table, the highest value or the largest value of the probability is only 0.5. All right. So you need to 1 minus the value of 0.83. Okay, since this is the greater, so probability of Z greater than negative Z is 0.83. It covers the negative side. All right. So actually it is equal to probability of Z greater than Z equal to 0.17 from the positive side. So 0.17, the closest value in the statistical table is here, 0.1711. So look at to the first column, 0.9, and plus the first row is 0.05. So based on the table, the probability of Z greater than 0.95 is equal to 0.17. Then equating the value, C minus 2 over 2 is equal to negative 0.95. This is because the value of 0.83 is at the left side, all right, or greater than 0.5. So you need to put the negative value. Therefore, the value of C is 0.1. And then the last one is probability of X less than C equal to 0.15. So you can see that the probability X less than C, so approximate to the standard normal distribution, probability of Z less than C minus 2 over 2 equal to 0.15. So this is less. So the value is negative. Z is less than negative Z. So it's actually equal to the probability of Z greater than Z because the value of the probability is still less than 0.5. So 0.5 from the table is the closest value is 0.1515. So the first row is referred to 1 and the first column 1, the first row is 0.03. So from the normal table, the probability Z greater than 1.03 is equal to 0.15. Then equating C minus 2 over 2, and don't forget equal to negative 1.03 since this is less and also the value less than 0.05. So the value of C is negative 0.06. Okay, let's say you are given the X normally distribute with 16 to 20 and the variance is 25. Find the value of X less than 22 greater than 11. So first, approximate to the standard normal deviation. So 11 minus mu, which is 16, divided by standard deviation square root of 25. Same goes to 22 minus 16 over 5. Then you have the value inequality in the standard normal distribution is probability of negative Z to 1.2. So for this, it's actually covered from negative to positive. So the the area under the normal curve is 1 minus the area of probability of z less than 1 minus the probability of z greater than 1.2. So based on the normal distribution table, you will have 1 minus 0.1587 minus 0.1151. Then you will get the answer is the probability of x from 11 to 22 is 0.7262. The next example is the mean of weight 200 people is 67 and the standard deviation is 7. Assuming that the weights are normally distributed, determine how many people have weight between 60 to 74 and second more than 81 kg. Okay, let X be the weight of a person. So X is normal distribute. The mean here is 67 and the variance is 7 square because this is standard deviation. All right. Then the question asks you to find how many people have a weight between 60 to 74 kg. All right. So approximate to the standard normal distribution. 60 minus mean 67 divided by standard deviation which is 7. 74 minus 67 divided by 7. Then you will get the value of probability of -1 to 1. So in order to find the area under the curve from -1 to 1 is 1 minus 2 multiply with the probability z greater or equal to 1. From the normal table, you will get the value of probability z greater or equal to 1 is 0.1587. Then the answer of probability people that weight from 60 to 74 is 0.6826. Next is let y be the person weight between 60 to 74. So y over 200 is equal to 0.6286. This is because the question asks you how many people, not the probability. So once you have find the probability, still remember the probability is the number of the event divided by total number and then is equal to the probability. So y is the number of people weight between 60 to 74 divided by the population 200 equal to the probability of the people that weight between 60 to 74. So y is equal to 136.52. Since this is person, so round off to 137 people that have weight between 60 to 74 kg. And then the next question is, how many people have weight more than 81 kg? So, probability x greater than 81 approximate to the standard normal distribution. 81 minus 67 divided by 7. So, probability z greater than 2. So, based on the table, probability of z greater than 2 is 0.02275. So, in order to find how many people weight more than 81 is, so now I let B to be the number of people weight more than 81. So B divided by total sample is 200 equal to the probability of the people weight more than 81, which is 0.02275. So B is 4.55, approximately to 5% that weight more than 81 kg.